This is number 13 on page 435. 13 starts off x squared minus 4y squared minus 2x minus 24y minus 39 is equal to 0. Well, let's graph these using our steps. First we have to decide which set of steps to use. Is this a hyperbola or is this an ellipse? If you look at this part here, we have an x squared and a negative 4y squared. Different coefficients and opposite sign. This has to be a hyperbola. Regardless, let's still complete the square and group these together. Okay, we got x squared minus 2x grouped. We have minus 4y squared and minus 24y grouped with a negative outside. So technically we kind of factored out a negative. I'm going to change that to a plus because if we were to distribute the negative back in, it'd become a minus again. And we're going to say equals 39. I'm going to move the 39 over because I've noticed a lot of you neglect that single term that's left on the left side. So let's move it to the right side. Okay, one little step before our box and triangle steps. I'm going to factor out the 4 because we do not want a coefficient in front of the y squared when we complete the square. So now we have x squared minus 2x plus a box minus 4 times y squared plus 6y plus a triangle equals 39 plus a box plus a triangle. And in the corner of that triangle, we're going to put a negative 4 because we factored a negative 4 out. And please show the boxes and the triangles because a lot of you have been neglecting to put 2 boxes and or 2 triangles. You forget to add it to the right side. Okay, inside the first box and the second box goes a 1. Inside the triangles goes a 9 and 9. When we rewrite, we get x minus 1 squared minus 4 times y plus 3 squared equals, this is 39 plus 1 minus 36, or 4. Divide both sides by a 4 and you get x minus 1 squared over 4 minus y plus 3 squared over 1 is equal to 1. This is usually how you know you did it correctly. You ended up with a pretty good looking hyperbola with perfect square denominators and everything was divisible. Okay, that is our graphing form. Step D, horizontal or vertical. This is a horizontal transverse axis because the x is first. Step C, we have one of our first off-center ones. The center is 1, negative 3. And now I'm going to start putting the grid up to graph this, as well you should, to get an idea for what this is going to look like. We're going to have a center at 1, negative 3, putting a point there. Now we do our little side break and we say a equals square root of 4, or 2. That is not because 4 is bigger than 1, that is because the 4 is first. B is equal to the square root of 1, or 2. And C, and off to the side we're going to remind ourselves that in a hyperbola, c squared is equal to a squared plus b squared. C squared is equal to 5, or c is equal to the square root of 5, or about 2.2. C is equal to radical 5, or 2.2. Let's grab that stuff and shrink it. So before we do part D, let's graph this stuff on here. Horizontal transverse axis. So there's our vertices. Oops. That should only be 2 over. Over 2, over 2. Up 1, down 1. And then right 2.2 and left 2.2. And you know what? I'm going to quickly change this over to be a larger graph here. Won't take but a second. Center at 1, negative 3. Left 2, right 2 and left 2 for our vertices. Up 1 and down 1 for our minor vertices. And then right 2.2 and left 2.2 for our foci. Okay, back to the steps. Step D, A equals 2, B equals 1. And step E, we found our foci at, well, our original point was 1, negative 3, and since we're going right and left, we're going to change the x This is going to be 1 plus or minus radical 5, comma negative 3. Or we have 1 plus 2.2 or 3.2, negative 3. 1 minus 2.2 or negative 1.2, negative 3. If you check the coordinates carefully, this one corresponds to that blue point, and this one corresponds to that blue point. So they are correct. Lastly, we graph. We graph by using our incredible hyperbola technique of drawing the box around each of the 4 vertices, the major and the minor ones. Then putting our asymptotes. While I'm doing this, you might as well do it on yours too. Okay, there's one. I'll get this other one going quicker. Put your pencil on the vertex, not on the blue point, but on the vertex. And we're going to go very close, but not touch. Very close. And we have drawn ourselves a pretty good looking hyperbola.